What would happen to our planets if the sun died? Would they survive or be destroyed? Would they remain in their orbits or drift away? These are some of the questions that astronomers have been trying to answer for a long time. And thanks to the James Webb Space Telescope, or JWST, we may have some clues. Hello and welcome to Curiosity, where we explore fascinating and interesting topics about everything. Today we're going to talk about planets around dead stars and what they can reveal about the future of our own solar system. The JWST is the most powerful and advanced space telescope ever built. It was launched in December 2021 and has been observing the universe in unprecedented detail and sensitivity. One of its main goals is to study exoplanets, which are planets outside our solar system. Exoplanets come in all shapes and sizes, and some of them are very different from anything we have seen in our own backyard. But among the thousands of exoplanets that have been discovered so far, there are some that are very special. They are the ones that orbit white dwarfs, which are the remnants of dead stars. White dwarfs are the cooling Earth-sized cores of stars that have exhausted their fuel and shed their outer layers. They are very common in the galaxy, and they are the final stage of most stars, including our Sun. But white dwarfs are not very hospitable hosts for planets. When a star becomes a white dwarf, it goes through a violent phase called a red giant. During this phase, the star expands enormously and engulfs the inner planets in its system. Mercury, Venus, and Earth will be vaporized by the Sun when it becomes a red giant in about 5 billion years. Mars may also suffer the same fate depending on how big the Sun gets. The outer planets, such as Jupiter and Saturn, may survive the red giant phase, but they will face other challenges. The mass loss of the star will change the gravitational balance of the system, and the planets may become unstable and collide with each other or be ejected into interstellar space. The debris from these collisions may also pollute the white dwarf with heavy elements, which are normally absent from its surface. Finding planets around white dwarfs is not easy. Very few have been detected so far, and most of them are either small, rocky worlds that were dragged closer to the star after its death, or large gas giants that were pushed farther away by the influence of other planets. But none of them resemble the planets in our outer solar system in terms of size, temperature, age, and distance from the star, until now. A team of astronomers led by Susan Mullaly at the Space Telescope Science Institute has reported the possible discovery of 2 giant exoplanets orbiting 2 different white dwarfs. These planets are more similar to Jupiter and Saturn than any other planets found around white dwarfs. They are also the first ones to be directly imaged by the JWST, which means that we can see them as separate dots of light next to their stars. One of the planets is about 40 times more massive than Jupiter and orbits a white dwarf that is about 60% of the Sun's mass. The planet is located at a distance of about 34.5 times the separation between Earth and the Sun, which is roughly the same as the distance between the Sun and Pluto. The other planet is between 1 and 7 times the mass of Jupiter and orbits a white dwarf that is about 40% of the Sun's mass. The planet is located at a distance of about 11.25 times the separation between Earth and the Sun, which is slightly farther than the distance between the Sun and Saturn. These planets are remarkable for several reasons. First, they are very young, only about 100 million years old, which means that they formed shortly after their stars died. This suggests that they are not the original planets of the system, but rather the result of a second generation of planet formation from the debris left by the red giant phase. Second, they are very warm, with temperatures ranging from 400 to 800 degrees Celsius, which means that they are still glowing in the infrared from the heat of their formation. This makes them easier to detect by the JWST, which is designed to observe the infrared spectrum. Third, they are very stable, with no signs of perturbations from other planets or objects in the system. This means that they have survived the chaotic aftermath of the star's death and settled into stable orbits around the white dwarf. These planets are not only fascinating in their own right, but they also offer a glimpse of what our solar system may look like after the Sun dies. They show that it is possible for gas giant planets to survive the death of their star and even form new planets from the leftover material. They also show that these planets may be detectable by future telescopes, which could help us learn more about their properties and histories. But how can planets form or survive around white dwarfs? There are different theories that try to explain this phenomenon. One theory is that some planets may have been originally orbiting the star at very large distances beyond the reach of the red giant phase. These planets may have been perturbed by the gravitational interactions with other stars or planets in the galaxy and migrated inward toward the white dwarf. This process may take billions of years and may explain why some of the planets around white dwarfs are very young compared to their stars. Another theory is that some planets may have formed from the debris disk that surrounds the white dwarf. This disk may consist of the remains of the star's outer layers, as well as the fragments of asteroids, comets, or planets that were destroyed by the star's death. The disk may provide enough material and time for new planets to form, either by accretion or by gravitational instability. This process may take millions of years and may explain why some of the planets around white dwarfs are very warm and bright in the infrared. A third theory is that some planets may have survived the death of their star by being shielded by other planets. For example, if a gas giant planet was orbiting the star at a safe distance, it may have protected a smaller planet behind it from the intense radiation and wind of the red giant phase. The smaller planet may have remained in a stable orbit around the white dwarf, while the gas giant planet may have lost some of its atmosphere and mass. This process may explain why some of the planets around white dwarfs are similar in size and composition to the Earth. These theories are not mutually exclusive, and they may all apply to different planetary systems around white dwarfs. The diversity and complexity of these systems may reflect the different evolutionary paths that they have followed after the death of their stars. By studying these systems, we may learn more about the formation and evolution of planets in general and the possible fate of our own solar system in particular. That's all for today's episode. Thank you for watching Curiosity. If you enjoyed this video, please like and subscribe for more content like this. And don't forget to share your thoughts and questions in the comments below. Until next time, stay curious.